Hey Kai, I cannot wait to dig into the latest performance improvements that we have in Tailpipe.
Sure thing. Okay, the first thing that we looked at was the memory usage. We noticed that for some tables, the memory usage was really excessive. For example, there's a table AWS cost and usage report. And when collecting that for any reasonable period of time, the memory usage would shoot up to 60, 80 gigabytes. And then quite often the plugin will crash, not surprisingly. So we took a look at that. And we found a few things. So we did some fixes in the plugin itself, um, but we also put some code into the CLI to stop this from happening in the future. And so basically, we implemented a bunch of memory limits, which I can show you. So now you can configure the max memory that the CLI will use, um, the max memory that each plugin instance will use, and also the maximum amount of storage space that is used during the process. Another thing that we saw is temp files are created during the conversion process, and when you're doing a big conversion, the volume of those temp files can really balloon up. So we just provided you with a mechanism to control that if you're working in a resource constrained environment. You can set those in the workspace, so you can put them into the default workspace or have a named workspace, and we got parameters for each of them.
Excellent. And I believe we could also set those as environment variables if we wanted to.
That's right. You can for each of those, there's also an environment variable.
Look at all that flexibility. Um, and I believe also we made some improvements around knowing when a plugin crashes because it'll happen, right? And
Yeah, absolutely. So that's one of the things that we saw during the memory investigation that, as I mentioned, the plugins would sometimes crash. And what we saw was that the CLI wasn't handling that well. It didn't notice that the plugin had gone. And so the collection would just stall with no feedback. So what we do now is we monitor the communications with the plugin. We can detect if that plugin crashes, and we can now provide a nice error message to tell you that that's happened.
can you tell us a little bit more about our changes to the hive partitioning strategy in Tailpipe?
Sure thing. Let me just flip over to the file view. So when Tailpipe collects data, it generates Parquet files and it uses Hive partitioning to store those files. This is a system where you put it into a folder structure where each folder basically represents an index key that you can filter on. And it's a mechanism that DuckDB uses to provide very efficient filtering over high data volumes. Um, Now, by default, we partition on the table, the partition, an index column, and a date. But what we found was actually DuckDB doesn't perform well if there are too many Parquet files. Both generating the Parquet files and also querying the Parquet files can be very slow and memory prone. Um, so what we've decided to do after a bit of analysis is to not populate the index column by default. We just set it to the word default. What this does is flattens all the files. So rather than having multiple index folders with date folders under each one, we now just have a single index folder. And that substantially reduces the amount of data files, which correspondingly improves the DuckDB performance and also speeds up the conversion process. Now, if you decide that for your use case, you actually want to have an index, it's useful to be able to filter on an index field, for example, an account ID, a user ID, or something, you can still do that. In your partition config, um, you can set a TP index property. And what that does is it defines a column which is used to generate the index column. So in this case, we're going to set the index to the AWS region. Now, any future collections we do for this partition will now partition by the region. Existing data won't be changed by default. If you want to update the existing data to use the new index, you can run the compact command and pass this new reindex argument. So if you run that, what this will do is go over all the existing Parquet files, rewrite them using the new index, and you can see We previously we had 900 files, 917. We now have 4,000 files because we're splitting them out into multiple files for each region. So if we go back to the vol data, so we can see now we've got multiple index folders, one for each region, and under each one we have the date folders and then the Parquet file. So you can see, you get a lot more data that way, but it might be useful for your needs.
Great. And there are a couple other changes and updates we've made to how we collect this data. Again, we were just showing, how we would recollect, but now we can collect using a to flag. We used to have just a from flag. Now we also have a to flag.
That's right. So previously, as you say, we could collect from a time period, but we would always collect up till now. But now you can specify distinct regions that you want to collect. So you might just want to collect for a single day, for example. So, for example, I can collect this partition from 3 days ago up until 2 days ago. That'll just collect one day. So if you've got very large data volumes or there's a particular region that you're interested in debugging, this is very useful.
And I can see in this case, there's two things that come to mind. So one is I really love the relative date shortcut that we can do, where instead of saying this date, we're saying T minus 3 days, T minus 2. That really helps us, and that's something that I think is a great helpful thing with this. Also, like you said, we collected from that one day, and I can see it didn't bring anything in because we already had data from that particular day. But what if we wanted to say, okay, that's fine. Maybe I had it, but I really, really want you to Tailpipe. I really want you to bring in and collect from that time, even though I already had data.
Yeah, that's interesting. So this is actually new behavior with this version of Tailpipe. Previously, whenever you specified a from date, it would always recollect all the data, which is pretty inefficient. Now, by default, it won't recollect if you've already collected the data. But what you can do is you can pass an override flag, and that forces it to recollect the data for that time. So now you'll see it's bringing the data in for that day. So it just gives you
what I like to call the I really, really mean it flag.
Exactly. Yeah. It just gives you a lot of flexibility to control exactly what the collection does.
That's really great. And I think just to round us out, there were a couple more great improvements around introspection and how we interact within the CLI itself.
That's right. Yeah, we've just improved the display output for some of the metadata. So, for example, format list command, we've added a location column. This tells you where that format is defined. So it might be in a plugin. So this tells you it's in the AWS plugin. Or it might specify that the format is defined in a config file. Another thing that we've added is more information in the source show command. We've added this properties field. So these are the properties of the source that you can configure in the HTML. So that tells you what config values are available for you to configure. It just makes it a lot easier for you to set up your configs. One more thing we've done is just slightly improve the autocomplete within the query editor. So now you can, for example, get table completion when you do commands like describe and explain. So it's just a little, quality of life improvement that we've done.
And speaking of a quality of life improvement, I can see that now we sort all of the TP meta columns at the end in our query, which is helpful grouping.
Just makes it a bit easier to see the columns that you're more likely to be interested in.
Thanks for watching. If you're ready to get started with Tailpipe, you'll find more information and a getting started guide at tailpipe.io.